Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to this lecture where we are continuing with our discussion or demonstration of this whole building simulation tool, Design Builder, as part of this ongoing online course on sustainable architecture. So far what we have done is we have learned how to create a base case building. We have also learned how to make changes and also create a proposed building. In today's lecture, we will see if not just for compliance, but to improve upon our design, if we want to check the performance of each energy conservation measure, how do we want to, how do we simulate, how do we take each energy conservation measure separately, also how do we calculate the average performance of a base case building. And then how to compare, how do we compare between a base case building's performance with that of the proposed case building's performance. So we move on to the Design Builder screen, and I hope that you are following up with us at the same pace at which these lectures are being delivered, so that you are absolutely in sync with whatever is being discussed here. It will be good for you as a hands-on exercise. So let us switch to the Design Builder screen now. So by now we have already completed our base cases and we have also completed the proposed case. Just to give you a quick recap, we have the input data for both the base cases and proposed cases here. So here we see location and weather file being the same, building type being the same, layout and zones remaining the same, gross floor area, total conditioned area, the number of floors, above and below grade, and floor to floor height. So the basic building geometry remains the same. We do not have to change that in the proposed case. In case of activity, the occupancy has to remain the same, the schedules have to be the same. So people come at the same time, the percentage of occupants, also on both weekends and weekdays. So the activity schedules remain the same. Now one thing which will change and which we have already changed is the construction template. So for the base case, we have the values which are coming out of the code. In our case, the relevant code was ECBC, and so the values which we have taken are from ECBC. However, for the proposed case, we can change these values. We can change them to anything, but if you look at the values in the proposed case here, they are very similar to what ideally the base case should be. So in case of the roof view value, instead of 0.25, we have proposed 0.26. For a wall view value of the base case as per ECBC, instead of 0.4, we have taken a better base case, a better proposed case, which with 0.34 U value, so which is even better. Similarly, for openings, fenestration, the U value has been further reduced from the base case 3.3 to 2.2, which implies that the proposed case should ideally perform better as far as its overall energy performance is concerned. Same as with SHGC and VLT. So we have a better VLT, which implies more daylight being available, and a lower SHGC, which implies lesser heat being brought in. However, what we have done here is we have increased the window wall ratio from 40% to 60%. So there are more windows, and we have also added the overhang. So this is what we have changed from the base case to the proposed case. We also changed lighting and HVAC, and we instead of the standard values which we got from the codes, we changed it to the technology which is available and the more contemporary numbers which are available in the market today. Once we have done the base case, and we also have the proposed case, we can do a direct analysis comparison between how the base case is performing or the proposed case is performing with respect to the base case. But to get a base case average, we have to orient the building in all directions. So, the first case which we took was oriented 0 degrees. Let us quickly look at the design builder here. So, if you remember our building, the building was not oriented like this. This particular case is the base case 90, where we have already rotated this building by 90 degrees at 90 degrees. So, if you want to rotate the building, you can just copy the file, the base case file which we have created, and we go to the location, and in site details we can change the site orientation to 90, and we just keep everything else as the same and we simulate it and we get the results. Similarly, we will develop the cases for 180 degrees and 270 degrees as well. All the 4 cases, and the average for them will be taken as the average energy consumption for the base case, the EPI. Here if you can see, since the building is a regular rectangle, even after orienting it twice, we would get the same values for 2 orientations, and for the other 2 we get the same values, and hence this average. So, and in comparison to that, the proposed case that we had taken gave us an energy consumption of 79.17 kilowatt hours per square meter per year, which implies that there is an overall energy saving of around 54.73%, which is a very good scenario. However, in real cases, we may not be employing all the energy conservation measures which we implemented or added in the proposed case. So, if we look at the energy conservation measures, we change the envelope properties, we change the glass properties, we change the window wall ratio, we change the external shading, we added, we change the lighting power density, we change the lighting controls, we added the lighting controls, and we also changed the HVAC system. Now, in real scenarios, we may not really be requiring all these energy conservation measures to be incorporated. In fact, since each measure comes at a cost, at a price, we might want to see what is the impact of this envelope, this energy conservation measure on the performance of the proposed case. So, what we do rather is we add each energy conservation measure step by step. So, we start from a base case and then we start adding the energy conservation measures. So, what we have done here is, if you do not consider these energy savings so far, but if we look at this matrix. So, what we have done is we have a base case which we have already shown how to do, and then to the base case we add energy conservation measure 1, which was changing the envelope properties, and then we simulate it. So, we have already developed a scenario, a case where the base case has been changed only or added with energy conservation measure 1 and then simulated it. So, if we look here, we have copied the same base case here, and we will, if we look at the different tabs, the rest of the properties, they remain exactly the same as that in the base case, and the only thing which will change here is the construction template. So, we change the construction properties. So, the flat roof U value and the wall U value. So, only these properties will change if we look at the ECM 1. So, here the envelope properties, only these 2 properties have been changed to get the proposed case with ECM 1. So, base case plus ECM 1 is this. In a similar manner, We would then go to the second energy conservation measure, which we have here. So, what we have done is to the base case and the ECM1 case, where base case at 0 degrees plus ECM1 was there, we also added the ECM2. Now, ECM2, so the ECM2 has glass properties changed. So, instead of the values for glass U value and glass SHGC, we have these values here for the proposed case. This is what, so here we have also changed the glass properties, which is the glass U value and glass SHGC. If we look at this particular case, in openings we have also changed the glass values. So, we have already changed the type of glass which is going to be used, and here it will be changed with the values. So, ECM1 plus ECM2. We are continuously simulating them and the results are being recorded simultaneously. So, we keep changing these values here, envelope and then added glass properties. In ECM1 plus 2 plus 3, we add further the window wall ratio. So, instead of 40% which was taken as the base case, we now have taken the 60% and then the energy consumption for them be recorded here. The normalized value, which is kilowatt hour per square meter per year, and the overall energy consumption value. So, as we go ahead, as we move on, introducing each ECM measure. Now, this is just one way of doing it. We can have multiple permutations, combinations, but we can see that, or we could also do it this way, where we just have the base case plus ECM1, base case plus ECM2 only, base case plus only ECM3 and like that. So, we know the individual effect of this individual ECM, or we could do it this way, or we could have some other combination. But what it will give us is, what is the impact of this energy conservation measure, which is here, over the base case. Now, if we see here, so if we see here, from the base case, after adding energy conservation measure 1, which was the envelope property, we got a saving of only 0.39%. Now, it appears that the envelope properties do not have much impact, but if we look at the input data, there is hardly any difference in the proposed case from the base case. So, the base case is already at a very higher level, very good value which should be there. Conventionally, these values will not be available. For having a roof U value of 0.25, we will have to add substantial amount of insulation to it. Similarly, for a wall U value, achieving it at 0.4, we have to have good amount of insulation being provided here, which will result in a high base case performance, as we are seeing here. It is a good base case performance. And on top of that, if we have changed the envelope property slightly, that is why it is not giving us much difference, much advantage over the base case. Here in this proposed case, we may decide that we do not want to add these envelope properties, we do not want to change the envelope properties at all, because the base case is anyways complying with it. Or the other scenario could have been where we change the envelope properties to make it lenient. So, instead of a proposed case of 0.26, we might have had a roof U value of say 1.3, which is absolutely not good if we look at the base case values, or the wall U value from 0.4 goes on to become 1.8, which is what typically we would get in a conventional building. And then we simulate, so here we would have seen that the performance dips down. So, it consumes more energy and there will be a negative number as far as energy savings are concerned. So, it consumes more energy. If we look at this particular table, we see here that the moment we increase the window wall ratio from 40% to 60%, we see a 4% dip in energy savings, which means that this option with more windows, having added 20% WWR consumes more energy. So, we know that higher WWR is going to result in more energy consumption. There could be another energy conservation measure here, where instead of a uniformly distributed window wall ratio, we might have, say, the northern facade with complete windows. So, we might have the entire north facade here with 100% windows. So, we can also change, if we wish, we can go to this individual wall. We can select a wall and we can change the openings on this wall. So, instead of 40%, we can make the openings to say 100%, but this will be only for this wall. So, if you come back, we can see that this entire wall has become a glazed wall. So, it is 100%. We can add all the zones, we can select all these walls and make it 100%. We can totally remove the windows from here, or we may reduce it to say just 10%. So, the overall WWR comes out to be 40% only, but the impact of it could be seen in the performance. So, we know that WWR matters, and any design strategy towards WWR will be accounted for here. The next what we did, we added external shading to the increased WWR, where we made it from 40 to 60, and we can see that immediately there is a substantial saving. So, just by adding external shading to all the windows, we have been able to bring it back to almost the same performance which was with 40% WWR and changed glass properties. Then next, once we have done with all the passive design parameters, next we moved on to the lighting power density. So, if you remember, we changed the lighting power density from 10.5 to 7. So, we changed the lighting power density from 10.5 to 7.6, and we can immediately see the savings being brought in. So, we have around 10.35%, 10.5% of energy savings being brought just by reducing the lighting power density, and it is very easy today. So, in any case, we have to use artificial lights, but instead of using the conventional lighting system, we may go in for lights like LED, which have better efficiency. On top of that, if the lighting controls are added, we get an additional saving of around another 12%. So, we can see that lighting controls, they are equally contributing as LPD, the change in lighting power density, towards bringing energy savings, betterment of energy savings. And the last, where we changed the HVAC system, because it was considered to be an air conditioned building, and the moment we changed the HVAC and we just changed the coefficient of performance and selected a better system, a better performing system which had higher efficiencies and coefficient of performances, we can see that there is an additional saving of almost 30%, which is a huge saving. So, we see here that all these systems, all these energy conservation measures have the contribution towards energy savings. Now, once we have completed all this exercise, it could be done individually or in groups or whichever way you want, but you will be able to have a good idea of how this energy saving is happening. And simultaneously, we can take the cost impact, the capital requirement for adding each one of this energy conservation measure, and we can compare whether the cost which is incurred in installing each of this energy conservation measure is worth looking at the energy savings they bring about with them. So, maybe that we would decide that we really do not need to increase the WWR from 40% to 60%. We might rather do with 40% WWR, or we may distribute it differently like on individual facades. LPD comes at a very reasonable price, it comes at a very little capital investment, and similarly lighting control, they require a little more capital investment, but the percentage of savings that it brings along is tremendous, it is huge. So, we make a wise judgment of how much of energy savings will be brought in vis-a-vis the capital investment which is required for each of these energy conservation measures. So, we will stop here today, and we will continue with few more tools which are available as part of the whole building simulation using Design Builder. So, thank you very much for being here with us today, and see you again tomorrow, and where we will be continuing with the software only. Thank you.